Hey kids, Miss Klinger here, who is going to go over your Algebra 3-4 Spring Final Exam Review. It's going to be just like I'm sitting there with you, but I won't be. So grab your popcorn, get a snack, get ready. We are going to start. So number one, remember if we've got a fraction, the way to undo it is to bring it to the negative first power. So let's... Oh no, I didn't mean to do that. I'm still getting used to this. So we can make this 1 over 6, 6 to the negative 1, but we still need it to the x. You can't get rid of that x yet. So 6 to the negative 1 power to the x equals, and then I'm going to copy down this right side. So 6 to the 3x plus 4. Now, remember, we've got up high, multiply. So it becomes 6 to the negative 1 times x is negative x equals 6 to the 3x plus 4. Woohoo! Why am I excited? I'll tell you why. I'm excited because my bases are the same. So when that happens, that means I can just write out the exponents. So negative x equals 3x plus 4. Get x by itself. This is some Algebra 1-2 stuff. Minus 3x. So I get negative 4x equals 4. Divide both sides by negative 4, so I get x equals b. Negative 1. All right, I didn't mean to do that. Let's keep cruising to number 2. So, same thing. In order to get that fraction not a fraction, I am going to change it to 25 to the negative first power. I still need my 3x up there. Equals 5 to the 2x minus 16. All right, kids. Here's the thing. 5 is not the same base as 25, so we just can't set the exponents equal to each other. I need to make that 25 with a base 5 too. So that becomes 5 squared to the negative 1 to the 3x power equals 5 to the 2x minus 16. So up high, combine all these. I'm multiplying together, so I get 5 to the negative 6x equals 5 to the 2x minus 16. And now I can set my exponents equal to each other. I'm running out of space. We'll do it right here. Negative 6x equals 2x minus 16. I'm going to subtract 2x from both sides. So I have negative 8x equals negative 16. So x equals positive 2. B es tu respuesta correcta. ¿Entiendes? ¿Preguntas? Okay, let's move on. There she goes. Oh, we got ourselves a snail situation. But before we can snail it, we got to get this little log part, this part, by itself. So to do that, I divide both sides by 3. And so I have, I have log base 8 of x minus 1 equals 2/3. And you're like, but I don't like fractions. And I say, don't matter. It's okay. Snail it. Start with the 8. Raise it to the 2/3 equals that. So 8 to the 2/3 power equals x minus 1. 8 to the 2/3. How do you know what that is? Don't matter. Type it into your calculator. 8 to the 2/3 equals x minus 1. I'll tell you what this is. It's 4. 8 to the 2/3 is 4 equals x minus 1. Add 1 to both sides. X equals 5. So your answer is D. 4 is just the same. We just have to do a couple more things before I can snail it. add 3 to both sides first. So you have 5 log base 4 of x minus 1 equals 5. And then divide both sides by 5. So I have left log base 4 of x minus 1 equals 1. Now I'm ready to snail her. So I go, let's do perps. 4 to the first power equals that. 4 to the first power equals x minus 1. What's 4 to the first power? It's 4. Add 1 to both sides. So I get x equals 5. That is option D. Any preguntas so far? Why don't you pause for a sec? I'll wait here. Get yourself a snack. Make sure you don't have any questions. Pause the video. Okay, let's move on. Number 5. Oh, this one. Oh, I didn't mean to do that. This one is so nice. They're both log base 7. When these bases are the same, woo! Let's just set them equal to each other. X plus 12 equals 4x plus 6. All you do is set this guy equal to this guy. Oops, I'm spitting on the iPad. Don't tell Ms. Zolden. Okay, so now I get x by itself, so it doesn't matter how you do it. I'm going to subtract 4x from both sides and 12. So I get negative 3x equals 0. 6 minus 12 is negative 6. Divide both sides by negative 3. Uh-oh, I messed up somewhere. Oh, no, never mind. I'm right. So x equals positive 2. Just like that. Solve x to the nearest hundredth. This bad boy is fun. Well, what you could do, since it's multiple choice, is you can plug in each one of these options for x in your calculator. 5 to this power, 5 to that power, 5 to that power, 5 to that power. See which ones gets you 56. That's not the technical way to do it. That's just a nice test-taking strategy. How I want you to do it, if you are so inclined, is take the log of both sides. So I've got log of 5x equals log of 56. Now, what I can do with that x, remember the laws of exponents, or the law of logs with it's an exponent, you can bring this down in front. So he becomes x times log of 5 equals log 56. I'm almost done. I need to get this x by itself, so I divide both sides by log of 5. Divide by log of 5. Then type into your calculator, log of 56 divided by log of 5. You will get 2.5. So that means your answer is D. Whew, if I'm getting bored, you guys must be dying right now. Let's keep cruising. Which expression shows the value of $10,000 investment after it has grown by 2 point blah, blah, blah per year for 12 years? Okay, this one is going to try and confuse you. Oh, wait, no, that's another one. This formula, remember, is y equals, we can call this P for the principal. Then we've got 1 plus or minus the rate as a decimal to the t power. Sorry, that took a little bit. So $10,000 is your initial investment. All of these have 10,000 up front, so I can't eliminate any yet. All of them has 12 for t, so I can't eliminate that. What does matter is that it's growing, so it needs to be greater than 1. B will not work because this right here is less than 1. I need this to be a decimal. So to change it from a percent to a decimal, move it over to the left twice. Put a little dot right there, and I need that 1 in front of it because it's growth. So I'm looking for 1.0225. If you said D, your answer is correct. All right, which one is an example of a growth function? That means whatever's in the parentheses, that B, needs to be bigger than 1. So, the only one that works is B. This isn't even an exponential function. This one's linear. Oh boy. This one is exponential, but 0.9 is less than 1, so it has to be B. Now we're going to talk about our buddy Scott. He needs at least $2,000 for a down payment on a car. So again, this equation, we're going to say A equals the amount that he needs equals principal times 1 plus or minus R to the T power. So he invests $1,000, so that's his P value, $1,000, in a bank that pays 6% interest. So that means his rate is not 6%. It's 0.06 because I moved that decimal point over twice. So $1,000 times 1 plus, because the account is growing, 0.06. And I want to know how many years. So I'm going to keep T like that. I want to know how many years until it equals $2,000. Again, what you could do for this one, it's multiple choice. You can plug in each of these answers for T, see which one will give you 2,000. That's not the technical way to do it, though. Technical way is let's divide by 1,000 first to both sides. So I get 2 equals, I'm going to add these together, don't freak out, 1.06 to the T power. Now, this is where it gets fancy. I got to take the log of both sides. Log aki, e log aki. So this becomes log 2 equals, remember that exponent can come right in front, equals T times log 1.06. Now I'm almost done. I can divide both sides by log 1.06. And that gives me my T in time. So T in time equals, type into your calculator, log 2 divided by log 1.06 should give you 12 years. Preguntas, you guys are troopers. Which one could be used to describe this function? For crying out loud, plug this into your calculator into y equals and see which one matches up. Best that I can tell you right now, it's exponential. This plus one means that it's being shifted to the left one, which doesn't really help us. It should be growing up like this. So we're going to cross out this bad boy because he's growing down. Geez, there's only one that works. This guy is decreasing. This guy's just wonky. We haven't seen anything like that. It has to be A. If you're stuck, try plugging in 0 for x. So f of 0, that means the y-intercept should be 2 to the first power is 2. This one is right because notice that it intersects right here at 0, 2. So again, use your graphing calculator on that one. This is fun. We got our little acronym right here. All students take. You thought I was going to say a drug, didn't you? Calculus. All students take calculus. So I'm finding cosine when theta is an acute angle. What does acute mean? Less than 90 degrees. That means it has to be right here. This is between 0 and 90. So what's positive in this? All of them. So I go through and look at all these options. They're all positive, so I can't rule any of them out. So this is where you use your pickup line. You guys are all going to be hits at the parties in college now because you're going to go up to someone, you're going to be like, hey, you, I wish I was sine squared and you were cosine squared, because then together we could be 1. I forgot my little thetas. So now let's plug her in. Sine is this. So right here I have something squared. That something is going to be 2 over 5. So I put a little 2 over 5 right there. Now 2 over 5 squared is the same thing as 2 squared over 5 squared. So I've got 4 over 25 plus cosine squared theta equals 1. Now I subtract 4 over 25 from both sides. So when I subtract this from here and here, I get cosine squared theta equals 1 minus 4 over 25. Geez, what is that? 21 over 25? Can I double check my work? Yes, 21 over 25. I'm almost done. Take the square root of both sides. Here's the thing. The square root of 21, that's not a perfect square. Leave it as the square root of 21. But for the love of all that is good and holy, little kids, what is the square root of 25? It's 5. Leave it like that. So B is your answer. Same thing. Okay. Sine theta is acute. So a smart trig class, whatever you want to use. We're looking right here, so all of these need to be positive, and they are, so that doesn't really help us. Again, bring out your favorite math pickup line. I wish I was sine squared, and you were cosine squared, because then together we could be 1. Now, I know my cosine this time, so sine squared theta stays the same, plus something squared. That something in this case is my 1 over 4. So it becomes, I still have sine squared theta plus 1 over 16. Don't you dare tell me it's 1 over 8. It's not. Subtract 1 over 16 from both sides, and I have sine squared theta equals 1 minus 1 over 16, which is 15 over 16. Square root both sides. So I get the square root of 15. That ain't going anywhere. And what is the square root of 16? 4. So C should be mi respuesta. ¿Preguntas? No? Okay. Real quick. Stupid joke of the second. What do you call... Oh, hang on. I forgot it. When a ninja goes to Whataburger... No. When a ninja goes to Burger King, what does he order? When a ninja goes to Burger King, what does he order? A whoppa! Okay. Find the value of cosine of 2 pi over 3. Here's a trick. You can type in cosine of 2 pi divided by 3 in your calculator. Make sure your mode is in radians. Make sure. It'll give you this negative 1/2. You should have your unit circle on your final too, so that'll tell you. Remember, cosine comes first. Cosine comma sine. If you forget, it goes in A, B, C order. Cos C before S. All right, 14. This is more recent, so this should be fresher in your brain. Which function has an amplitude of 8 and a period of 2 pi? So amplitude of 8 means that first thing, A should equal 8. So A is okay because there's an 8 right there. 1/8 is not that. C is still okay. The negative just means it's reflected. We're not going to rule it out yet. D is okay. So B is so far the only one we can rule out. A period of 2 pi. Here's the thing. Remember a period? You find a period by doing 2 pi divided by B. B is that number that's right in front of the x or the theta. So in this case it's pi. In this case it's 1. In this case it's pi. In this case it's 1. So we have to figure out 2 pi divided by b. We're looking for a period of 2 pi. So that means it would have to be 2 pi equals 2 pi over b. So naturally b has to equal 1 because the only thing you can divide 2 pi by to get 2 pi is 1. So I already eliminated b. That means my answer has to be D because there's nothing in front of this x right here. All right, this is a solid graph one. What I'd recommend on these, don't tell, plug it into your graphing calculator. Make sure you're in radians because as I see here, these are negative pi, negative 2 pi. So that's what's going to be that helps you out. What's the amplitude? 2. So that means your graph darn well better go up to 2 and down to negative 2. So I can cross out B because see, it only goes up to 1 and down to negative 1. Same thing here with C. So I'm torn between A and D right now. It's sine. So when it's sine, does that mean it starts at a crest, trough, or midline? Great. Sine starts at a midline. I feel like I'm Dora the Explorer. Click on the midline. Boom, the midline's right here, and it's right here for this one. Notice D, though. Where does D start if this is where you're starting? It starts at a crest. A starts at a midline, so that means A is your correct answer. All right, I got some converting. When you're converting radians to degrees or degrees to radians, you're always going either pi over 180 or 180 over pi. And you say, but Miss Klinger, how do I know which one? This just needs to cancel out. So 3 pi over 4, if I try doing pi over 180, I'm left with 3 pi squared. That's ugly. I don't want that. So then I know, oh boy, that I have to go 180 over pi because, whoopah! Those pi's cancel out, and I'm left with 180 times 3 divided by 4. 180 times 3, I don't know what that is. Hang on, let me get a calculator. 180 times 3 is 540 divided by 4 is 135, which is A. We okay? All right, least positive angle measure, coterminal, blah, 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 blah. So this just means when you're seeing coterminal or anything like this just means you're adding or subtracting 2 pi until you get to a negative. If it's asking for negative, this says least positive. So that means you keep subtracting 2 pi. When you hit a negative, you've gone too far. So 19 pi over 6 minus 2 pi. Take your calculator. I do 19 divided by 6 minus 2. Math, enter, enter. That gives you 7 pi over 6 because I put my pi back in there. So I've got 7 pi over 6. I'm going to try subtracting 2 pi again. If it gives me a negative, then that means my answer will be 7 pi over 6. So minus 2 pi. I do 7 over 6 minus 2. Math, enter, enter. Uh-oh, this is negative 5 pi over 6. So the least positive is going to be 7 pi over 6 because if I subtract 2 pi again, I get a negative number, and it wanted the least positive. So why is it 2 pi? It's 2 pi because there are 2 pi radians in a circle. This radius length, if I were to take this radius length, it'll go around the circle 6 times and a little bit. So it's always 2 pi. Pop quiz, if it's in degrees, what do you add or subtract? Yay! 360, because there's 360 degrees in a circle. We're almost done. Ooh, I got a Groupon notification. And a snap. Okay, back to it. 60 degrees to radians. Same thing, 60 degrees. Which way do I go? Well, degrees is on the top, so degrees needs to be on the bottom, which means my pi is on the top. Now, all this one is 60 divided by 180 with a pi on the top. So 60 divided by 180, math, enter, enter, is 1/3. Keep my pi on the top. So this one has to be B. One more joke. For those of you that aren't in my class listening to this, Miss Oldenites, here's a good one. Why is the ocean blue? Because all the fish, when they go swimming, they go bloop, 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 bloop. Oh, that's good. Okay, number 19, amplitude is whatever comes in front. So amplitude is 4. I can already cross out B and D because it's saying the amplitude is 8 and 2. Heck no, it's either A or C. And my period. Now remember, my B is 2 in this case. But my period is 2 pi divided by B. So in this case, it's 2 pi divided by 2. So my period is pi. My answer is C. The correct answer for 19 is C. Phase shift. Phase shift, you're looking right here. Did anybody know this is called the argument? Whatever's in the parentheses of a trig function is called the argument. This one's trickier because it's always the opposite of what that sign is. So if it says plus, it means minus. It means left. So this is going to be left pi over 2. And I think the last question, this is the last, no. Yeah, the last question is going to be a ball is hanging from a spring. All of these, please, 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 all of these, make sure that you draw a picture of what you think it's looking like, whether it's this or a Ferris wheel. I don't want you to get this wrong just because you can't picture it in your head. So here's going to be my little graph. If you were given a Ferris wheel problem, draw your actual Ferris wheel. Oh boy. There I am, me and my dogs. Okay, the ball is pulled 5 inches below its resting position and then released. So it's pulled 5 inches below. We're going to assume it goes up. 5 inches below and then released. Okay. Let's figure out first if it's sine or cosine. Sine always starts at the midline, so I know it's not sine. If it were sine, it would have to start right here. That's not the case, though. So I can cross out C and D because they're both sine. Positive cosine starts at a crest. Negative cosine starts at a trough. So without even figuring out using this 8 seconds, like you don't even have to use the period, you know that your answer is B. Alrighty, kids. Good luck on your final. If you're one of my students and you're listening to this on Friday, I missed you so much. But now you're to call me Master Klinger because I have my master's degree now. And when I come back, I'll get my doctorate. We'll talk about that later. But I'll be Dr. Klinger one day. Mark my words. So good luck on your final. Email me if you have preguntas over the weekend or message me through Canvas, and I'll try and respond to that. Good luck.